Now, in this video, again, we are going to solve two problems on simple stresses and strains. In last video, we have solved three problems. So now we have this question, that is a steel bar 35 mm by 35 mm in section and 100 mm in length. So we have this will be L, and then you can take B and T anywhere, any dimension, because it is same. So we have this will be B and this will be T. Then along the 180 kilonewton along longitudinal axis, so it is mentioned tensile 180 kilonewton, show compression, so it is wrong actually. So we have this as 180 kilonewton tensile. Then we have 400 kilonewton and 300 kilonewton. So we have these again tensile forces, 400 kilonewton, and then we have this as 300 kilonewton. Change in the dimension of the bar and change in the volume. E is given 205 and actually mu is given 0.3. If not given, you have to consider that value. So now we have this given data very clear. Now we have to find change in the dimension and change in the volume. Now change in the dimension, we have delta. So I will start with given data we have here. So you can write here given data. In exam, you have to draw the diagram again, and then you have to write E205 into 10 raised to 3 Newton per mm square and mu 0.3. Now first we have delta L by L. So now first we will go change in dimension. So change in dimension and then change in volume. So change in dimension in this we have delta L by L is equal to sigma 1, I will say sigma 1 for it, minus mu sigma 2 minus mu sigma 3 by E. Now sigma 1, sigma 2, sigma 3 we have to find. Now we have to consider this 180 kilonewton which is along the longitudinal axis. So I will write sigma 1. So what we will get? Sigma 1 that is equal to P1 by A. Now we have P1 180 into 10 raised to 3 and area, now it acts on which area? That is other two dimensions. So that is 35 by 35. Because perpendicular area for 180 kilonewton is this, that is 35 into 35. And we have this value that is 146.94 MPa. So we have value 146.94 MPa as it is given tensile. So all values we have that is positive. So now sigma 2. Now you can consider any one. So let us, we will say this will be sigma 2, will develop sigma 2. So it will act on 35 and 100. So we have equal to 400 into 10 raised to 3 and divided by 100 into 35. And we will get this value that is 400 in upon 100 into 114.29 MPa. And third it acts on again, that is sigma 3. So remaining, so for this 300 upon, again we have area 300 into 10 raised to 3. 300 into 10 raised to 3 upon 100 into 35. 100 into 35. And we will have this value that is equal to 85.71 MPa. And now we will calculate one by one values. So delta L by L, we have sigma 1 now, 146.94 minus, now E is same for all, denominator is same. So I will directly go 0.3 into sigma 2 114.29 and minus 0.3 sigma 3 is 85.71 and divided by, we have value of this, that is 205 into 10 raised to 3. And from this we will get value of delta L by L. We have this value equal to 0.000424. This is epsilon L, I will say, and no unit. But from this we can find delta L, which is equal to 0.00424, and length we have given, that is 100. And we will get increase in length, that is equal to 0.0424 millimeters. Then we have to go for other two. Then we have delta B by B. Now, which we have considered as B? So we have considered this as B. So we have to consider stress, that is sigma 2. So we have, this will be sigma 2, we have 114.29. So we have delta B by B 114.29 minus mu sigma 1 0.3 into 146.94 minus 0.3 into 85.71 divided by 205 into 10 raised to 3. So 205 into 10 raised to 3, you will get this value, that is equal to minus point. So just check. So no minus 0.000217. So this is alpha epsilon B. So delta B by B. And if we will put value of delta B here, then we will get, therefore delta B is 0.000217 into 35, and we will get this increase is 0.0076 millimeter. This is second increase in dimension. And then third we have, which is epsilon T, delta T by T, and change we have 85.71 minus 0.3 into 146.94. Just check it in calculation. I have taken 205 or 200, please. If it has considered 200, then please consider as 205 and you can solve this. So we have 205 into 10 raised to 3. And from this we will get value of delta T by T, which is equal to minus plus 0.000358. And from this we will get delta T, which is equal to 0.000358 into 35, and we will get delta T value, that is equal to 0.00125 millimeters. So these are the three dimensions which are increased. Now we know, second we have change in volume. So change in volume, and we have, this will be equal to delta V by V, and that is equal to epsilon L plus epsilon B plus epsilon T. And if we will put values in this, that is 0.30424. So 0.30424 plus. So these values we are substituting, strain values. plus 0.000217 plus 4 times 0.358. And from this we will get value of delta V by V 0.000677. And from this we will get, therefore, delta V is equal to 0.000677 into volume, and put a value of volume 677 into 100 into 35 into 35. And from this we will get delta V equal to 82.91 millimeter cube, and value is plus, so it is increase in the volume. So likewise we have to solve the problem. Now this last we will go with a composite bar is rigidly fitted at the support A and B, determine the reaction. Now see what is given, area is given. We have formula bars in series. Now given data, so we can have over here, that is ES 200 into 10 raised to 3 MPa, alpha S 12 into 10 raised to minus 6 per degree centigrade, E aluminum 70 into 10 raised to 3 MPa, alpha aluminum 11 into 10 raised to minus 6 per degree centigrade. Area of steel 300 and area of aluminum 600. Now we have formula when bars are in series, if you remember. So we have, this will be, now I will write L aluminum plus alpha aluminum into alpha aluminum into T aluminum plus L steel, alpha steel into T steel, and that is equal to PL upon AE of aluminum plus PL upon AE of steel. Now we will solve this. L we have for aluminum 1000, you can see L we have 1000 for aluminum. Alpha for aluminum is 11 into 10 raised to minus 6, and T that is given as 20, plus L for steel is given 3000. Alpha for steel is 12 into 10 raised to minus 6. Temperature we have 20. And then we have equal to P, we have same for both. So I will take common. And in bracket we have L for aluminum 1000. Area for aluminum we have 600 for aluminum. And E for aluminum is 70 into 10 raised to 3. Check it once. Data we have substituted is correct or not. So plus for steel, we have area L 3000. Then we have A that is 300, and E we have 200 into 10 raised to 3. And now if you solve this, we will get left hand side 0.94, which is equal to P in bracket 7.38 into 10 raised to minus 5. And from this, if you solve, you will get P that is equal to 12.74 into 10 raised to 3 Newton. We know reaction should be same because we have summation Fx equal to 0. So 12.74 kilonewton. And if you will see this, then we are going to get reaction at this. So now temperature increases. So we have reactions as compressive. So we have this reaction 12.74. And we have this reaction 12.74. So in examination, you can draw this diagram. You can show aluminum. So this is 1 meter. Be careful with this. And this will be greater than aluminum, 3 meters. And then you show these forces. So tensile, compressive force, because it tried to elongate. And therefore we have reactions in this fashion which are compressive, 12.74 kilonewton. So now we will stop here only today. So remaining part we will see in the next video. So my WhatsApp number is 70388 31674. You can have contact in this. So thank you.